The objective of this example is to develop a microservice within the Spring framework and deploy that microservice via AWS Elastic Beanstalk. The title is Microservices and APIs via Spring Framework for Elastic Beanstalk. Now, you will need to be familiar with Java code development as well as use of the Amazon Web Services web console for this module, but these are things that we've covered in several of the prior modules, so hopefully if you've gotten to this point, you should have the appropriate experience. As usual, the video is divided into subsections indicated by the labels at the bottom of the screen. This will allow you to manually navigate the lecture. So you've been provided a folder with several supplemental resources that you may download and use. The main resource for this project, or the main resources for this project, are named Artifact ID, as well as Artifact ID for Beanstalk. As you can probably guess, the difference is one we deployed locally and one we deployed on the cloud. However, we will highlight other resources during the lecture, and they have labels like RES and then some numbers following it. I hope you'll consider joining my mailing list. No spam, just updates and corrections to lectures. Link is on the screen. Also, please subscribe to my YouTube channel. Tons of free lectures. That link is also going to be on the screen in a second. Now, what topics are we going to discuss in this module going from beginning to end? We are going to go over the background of service-oriented architectures, background of APIs, as well as very brief background on the Spring framework. Then we're going to jump into the example itself, or the steps of the example, which will include defining our API structure, what is the API or set of microservices that we want to implement, what we want to achieve. We're going to talk about initializing the Spring framework-based project, developing our Java source code for the microservices, compiling and running our microservice, testing it. There's a slight detour where we need to worry about the specific way in which we set the port number to make sure that it runs on AWS. Then we're going to deploy our microservice to Beanstalk, Elastic Beanstalk, and then finally we'll talk about some potential applications and why I really think this is such a cool module and one that will be very useful practically to those of you that are doing this type of software development. Anyway, let's begin by talking about service-oriented architectures. Next, we want to discuss some architectures that are very useful to those developing software related to the Internet of Things, an area of special interest to me. This example, however, will also be beneficial to anyone who works with applications that can benefit from a more distributed or cloud-based implementation. A service-oriented architecture, or SOA, is one that emphasizes the organization of an application functionality as a collection of services. These services are provided to other components through a communication protocol and associated network. These services should have several key characteristics. First, they should be self-contained, or at least appear to be self-contained to the client. The client makes a request, supplies appropriate information, and receives a response. Note that a service may in and of itself be composed of other services or make requests to other services. This is what I mean by the appearance of being self-contained. It should also have a black box representation, meaning that the client has nor needs, doesn't have nor doesn't need any understanding of how the service works. Most of you that work in programming understand that term black box. Third, it should have a well-defined and predictable operation or functionality. The service should perform a concrete task and in return a result that the client understands. And one way to support this is through very clear documentation. Now, one type of SOA, service-oriented architecture, is the microservice architecture, where the services are designed especially to be small and light. It reflects a very modular and distributed design methodology where the client is expected to call only those microservices needed in order to achieve a larger objective or goal. An effective microservice is, as described by the Unix philosophy, an object that can do one thing but do it very well. The next section is on APIs. Note that we did talk about application programming interfaces, APIs, in the background module for this course. We'll do a quick recap here. The communication between a server and client may be defined by a remote or web type application programming interface, API. and its associated libraries. This allows a developer to communicate with an external service like Amazon Web Services using methods that are within a given programming language. This provides an additional layer of abstraction where the developer does not necessarily even need to know that they are communicating with an external service. Now, why are we discussing this now? Because we can use microservices to build a basic API to be used in a distributed type application. An API can be visualized as a collection of services, and the SOA architecture provides a scaffolding for the development of the services that comprise an API. The next section is the Spring Framework. For this example, we'll be using the Spring Framework to implement our microservices. It's an application framework for the Java platform that helps us structure our microservice project. If you have more questions about Spring, we're going to suggest that you take a look at the online documentation. It's pretty straightforward, and there's really not too much of a need for us to go too much deeper into that topic here. So now let's start on the example itself. Step number 1, define the API structure. In the development of Internet of Things IoT hardware with internet connectivity but potentially limited computing power, it could be very helpful to unload certain processes to a microservice hosted by another object, potentially in the cloud. In this example, we're going to try to develop our own basic API consisting of 2 microservices. The first is going to have the title or the name of generate random number. We'll talk about what the rest of this string means in a second. This microservice accepts a single input called input string, and it returns another string combining the input and a randomly generated number. If we assume that our request is being made via browser, then the input string must be embedded within the URL of the request. Hence the inclusion of the question mark to separate the URL location and the key value pair. So if we take a look at the different pieces of this command right here, or of this URL, you'll see there's 3 different pieces. Right, you have your URL pattern, which we're including. It allows us an additional level of distinction to define the location of our microservice. Then we're giving it a name, and then we have an input that is going to be passed to it, and that is encoded within the HTTP request. The next microservice has a similar structure, uses the same pattern. The name is going to be capitalized, and again, it's going to have an input string that's embedded within the URL. So the second microservice accepts a single input again called input string. It returns a capitalized version of that string. Obviously, these are trivial examples employed to demonstrate the method, but just really quick recap. We have 2 microservices. We have generate random number, and we have capitalize. Both of them accept an input string and do different things with them. Step 2, initialize Spring, or quick start for Spring. For additional background on this section of the module, please check out the resources that are provided to you. There's resource 10.1. We're going to begin by going to the Spring Initializer, dictated by resource 10.2. Fortunately, this website, which is shown right here, the Spring website automatically generates the project folder we need to build our microservice. Very convenient. So we're going to use the setup parameters shown below while making sure to include the Spring Web Library in our project. So let's take a look here at what's going on. So you can see first, we go to the URL provided, which brings up the Spring Initializer. We are going to choose a Maven type project to be written in Java, and we're also going to be choosing one of the newer versions of Spring Boot called version 2.4.5. If we scroll down a little bit, we get to this part of the screen over here where we entered several different parameters. We give it a group ID, we give it an artifact ID, and we give it a name. So all 3 of these apply to our set of microservices. The description is given right here, and then the package name is automatically generated. We are going to package our project as a .jar file, and since we were already working with Java version 8 in the previous module, I'm going to go ahead and just stick with Java version 8 for this one as well. We could go back to using a higher version as we did in one of the earlier modules, but at this point there's really not too much advantage to doing that. Now, if we scroll down a little bit more, that'll bring us to this part of the screen. We do have to make sure to add the required dependencies. There's only one that we're going to need for this example, and that is Spring Web. So you can simply type into the search bar Spring Web, click on it, and that will allow you to install or generate those dependencies. So once we click generate, a zip file should automatically be downloaded to our machine, and we're going to keep the initial name that was given to it of artifact ID. You'll note that it takes that name from this line right here and uses that as the name for the folder. Okay, step 3, we need to make changes to the Java source code. So what does that mean? They provide us a really basic framework that allows us to develop a microservice, but it doesn't contain any microservices in it. So what we're going to do is take those source code files, add our microservices to them, which I'm going to show in detail, and then we can simply package that and use it locally, or we can upload it to Elastic Beanstalk. We're going to do both. So next, we will make changes to the Java source code within the artifact ID.zip package, the one that we just downloaded a second ago. We unzip the package, and that yields a folder with the same name. We find the source code we are looking for within the artifact ID, source, main, Java, group ID, artifact ID folder. And it should have a name ID application.java. Now, this directory may seem like it's very confusingly named, artifact ID folder within an artifact ID folder. I could have simplified it, but I wanted to keep it in the same form as what we downloaded. And so that's the reason why it's a little bit convoluted. So when you download a folder, a zip file from the Spring Initializer, it's going to be given to you in a format that very closely resembles what I have here. All right, so let's take a look. Right, you'll see this is the location of your Java source code. This is our root folder, artifact ID. And then there's the subfolders that are within it. And you can see our source code Java file. Now, we're going to open up this code in Notepad++. I mean, you could use any simple IDE. And you'll see this, which is highlighted below. It provides a scaffolding for a microservice, but no request handling capability. You'll see that this source code is available to you as resource 10.03. All right, so what do we have here? A few basic pieces. We define our package. We import some libraries. We define our class. And then we have a main function defined. Below is where we are going to define our microservices to be used. So now we are going to add 2 new URL pattern mappings to the framework as shown below. And these are going to correspond to the microservices that we want to generate. The revised code is provided to you as resource 10.04. So what did I do to take this code right here and change it to the revised code below? A couple different things. We needed to add some additional libraries to provide us the functionality we need. And we also added a annotation for a REST controller. So this annotation simplifies the creation of RESTful services, combining the controller and the response body. Now, I could go into more detail about this. Again, this is going to be a place where I'm going to sort of draw the line with regards to depth. If you have questions about this, I recommend you take a look at some of the Spring framework or Spring Boot documentation. So what this means when we use this REST controller annotation is that we don't need to annotate every request handling method with the response body annotation. This annotation tells Spring, when I say this, I'm talking about REST controller, this tells Spring that this code represents an endpoint that should be made available over the web. Okay. The name of our application or of our class is going to stay the same, and this main function also stays the same. All it really tells the machine to do is to run, right, our Spring application. Okay, now let's take a look at the microservices that we added. You'll see that there are two. So I'm going to draw some lines to dictate where they start and end. Okay, so here we have the beginning of the first microservice, and then we have the beginning of the second microservice, and this is the end of the whole code. Okay, so what do we need to do? The first thing we need to do is to define, using the @getMapping annotation, the URL pattern that is going to lead to this microservice. If you look, you'll see URL pattern A, generate random number. This is the exact same pattern that we used right here. And you'll also note that the other pattern is going to be the annotation for the second microservice. So what we're doing in this part of the code right here is telling Spring, the Spring framework, how we want to access our microservice. Next, we need to define a method called method A. Well, I actually called it A1. You could name it anything. It accepts a string referred to as input string within the request, as well as string input 002 within the Java code. We'll talk about the relation between those two in a second. Note that the value of input 001 is automatically transferred to string input 002 by the nature of how this code is written. We're going to talk about that. Also note that the @request_param annotation tells Spring to expect an input string value in the request. So the annotation we're talking about here, @request_parameter, is simply telling us that, the Spring framework that it should expect a value to be passed with a key of input string. And if it doesn't receive that, it'll use a default value of nothing. Now, whatever is provided here will automatically, as part of the Spring framework, be transferred over to string input 002, and that is the value that we are going to use below right here. Okay, so this line essentially defines the method as well as the input coming in and how that's going to be accessed in Java. All right, so what happens in the body of this microservice? We define a random number, we convert it to a string, and then we concatenate the random number and the string input. So you'll see it's going to return something that says message returned : and then it's going to give us the string as well as the random number. So the string is s input 002 and the random number is s random, coming from right up here. The second URL is shorter, but only because I didn't comment it as much. We already should be able to extract those same concepts from the first microservice. So the mapping for the second one is going to be URL pattern A, capitalize. The method is called method B2. It also accepts an input called input string. It transfers that over to string input 003. And then the message return is simply going to be that string converted to uppercase, and so hence it capitalizes everything. So this code, the combination of resource 10.03 and 10.04, provide you a good beginning and end point for these microservices. What does the code look like in the beginning when we first download our folder from the Spring Boot initializer, and what does it look like after we make the appropriate changes to it? I think also that we've done a pretty good job of explaining how to create your own microservice. Okay? We've defined the basic pieces: your input, your method name, your mapping, as well as the core functionality. So you can use those, you can use that structure and do anything. Really, the sky's the limit here. Before we moved on, I did want to take another minute to talk about the structure of the microservice. I think we did a pretty good job in the previous part here using the example code in order to demonstrate the pieces of the microservice that are important. However, because it's such an essential part of this section, I figured it bared enough importance to repeat, or to say, let's go over it again. Now, what I did was I drew up the basic parts of the microservice and I kind of color-coded things. So what you see in blue, those are pieces of the code that are predefined syntax. You have to use those keywords. The parts that are in green are variable names, variable types that you are defining yourself. Yellow is some pseudocode, and then gray is comments, and red is just an arrow showing how one variable is used in two different places. So let's start from the beginning here. Okay, first you need the get mapping annotation, and you need to define in here the pattern and the microservice name, which I think for ours was URL pattern A, and then I guess one of them was capitalize. And so this is that which you actually have to put within your HTTP request in order to access the appropriate microservice. And so you define that right here. Next, we define a public method, and the type that it returns you define, so it could be a string, could be an integer, and then the method name itself you also define. There's not really too many constraints here. You can define this name any way you want. It doesn't have to match any other value, source code name, variable name from our microservice definition. Next, you have the request param annotation, which asks for two different values. Okay, first, right here, we have the key to be used in the HTTP request. So normally when you bring up the HTTP request or you call it in the browser, you have pattern, microservice name, and then / and you'll encode the name or the value that you want to pass to your microservice. So those three to go together. You have 1, you have 2, and you have 3. And again, you can define this however you would like. It doesn't have to have any relation to another value in this code. You also want to define a default value, and that will be passed to here. So essentially, either the name or the variable that you pass embedded within the URL, or if you don't pass one, the default value, one of those two will be passed as the input to our function. Again, you can define whatever type you want, and you can give it any variable name that you want. I think in our example, we use sinput 002. Now, this variable right here is going to be that which is called within the body of your microservice. So you want to do something to your input, which is that same any variable name that we used right here, hence the red arrow showing that it's the same variable. And the part that's in the yellow, this is where you can use your creativity and define whatever functionality you need. And at the end, you want to make sure to return your output variable name, which will go up here and then get passed back to the client who is making the request to the server. So you can see here that there are several important pieces of the microservice that we need to define in order to achieve the functionality that we're looking for. Step 4, compile and run the microservices. So next, we're going to change our directory to the root folder of our project, and you'll know which we're talking about because it should be that which contains the pom.xml file. I know it's a little bit confusing because we have multiple folders that are named the same thing. And so we go to that folder and run the application using the two commands below. So first, we change the directory to the appropriate folder. You can see here that we have really a weird root folder where it's artifact ID with a subfolder of artifact ID within it. Again, I kept it the same as it was unzipped from the initializer. So we need the second of those two folders. So we change the directory to that folder, and then we call this command right here, which runs the Spring Boot application. And so here you can see an example of this being executed on my machine. So right here, we change the directory. Right here, I ran the appropriate compiling command. And then you can see a whole bunch of other stuff is shown. And then at the end, we have no error messages. So that's a good thing. All right, next step. Step number 5, we want to test our microservices. So since we didn't make any changes to the port-related parameters, our microservices will be available at the URLs below. We're going to talk about the ports in a second. Don't worry. So note that we embedded a string of Professor Deese in the first request, and I like turtles, little bit of a internet joke right there, in the second one. So let's take a look at what we entered. So for the first test, we used the default port 8080, so localhost colon 8080. We have our URL pattern A, our microservice name, and then we passed the appropriate input. And so what was the output that we got from that? We get this down here. You can see the same URL is supplied. So a message returned, Professor D's, and then a random number that's generated. Now we test the second microservice. Localhost colon 8080, URL pattern A, capitalize, and then we embedded a different string, which is I like turtles. So if we take a look at that over here, again, we entered our URL. This is just a basic browser. I think I've talked about this at several other points in these modules, but just to clarify again, right, we can use any browser here, Chrome, Edge, Mozilla, whatever. And so the message returned is I like turtles, and now it's all capitalized. We haven't really talked about command line calls in this module. However, note that you can make the calls as shown below. Newer versions of Windows 10 include the curl functionality or the command URL functionality, and we don't need to install it separately. Before, from what I remember, as little as a year and a half ago, we had to use applications like Cygwin. So I can zoom in right here, and you can see that what I did was I made a curl command including the same URL, and we had a message returned. Then I tested the second microservice again with a curl command, and the same message was returned. So there's two different ways that you can test this. You can use the browser, or you can use the curl command. Okay, now next, step number 6, setting the port number. So above, we were just using the basic 8080 default. However, that's not going to work for our entire example. We haven't discussed explicitly how to change the port used by our microservices. It's a very easy change within the Spring framework. We have to go to the artifact ID source, main, resources folder, and open the application.properties file, and you can use Notepad for that or really anything. Now, we want to change our port number to 500 for the next part of this example, and that has to do with compatibility with Elastic Beanstalk. So we're going to add a single line that says server.port equals, and sorry, this should be 5,000. Server.port equals 5,000. So I went into the appropriate folder, I opened the application properties file using Notepad++, and it was blank because I hadn't added anything to it yet. And so I entered a single line, server.port equals 5,000, saved it, and then we're good to go. Now, if you were to run these examples up above one more time, note that you would have to then change this to 5,000 from 8080 because we changed our port number. Step 7 is to deploy this to Elastic Beanstalk. So from this point forward, we're going to be using the resource artifact ID for Beanstalk as opposed to artifact ID. So for pretty much everything that's up above, we were using the artifact ID resource. For everything below, we'll be using the second version. This copy should already reflect the port change. We only made a copy to prevent messing up the functionality from our previous example. So I just like to create different copies. That way one doesn't affect the other, or one part of the example doesn't affect the other. Now, before we can deploy our microservices, we need to package them properly using the command below. We're simply going to call nvnw package. And this should be after we change the directory to our root folder, the same that we used above. Now the result is a jar file with the name of artifact ID, which is the same as the name of our project, -001-snapshot.jar, and this is going to be within our artifact ID for Beanstalk, artifact ID target directory. And then this is the file that we are going to upload to AWS Elastic Beanstalk. So here you can see our root folder. Here you can see the subfolder within it. Then we go into target. And after we run the packaging command, we should see a file here, artifact ID -001 snapshot.jar. Now, we're going to upload that file to Amazon Web Services Elastic Beanstalk. We've already done one module that required us to use Elastic Beanstalk. This is going to be relatively similar, and you should, again, you have some experience working in this area, so it should be a little bit easier. So let's follow the setup procedure that's really close to what we used in the previous modules. All right, so we create a web app. I'm going to give it a name, DES Microservices 0416. The platform that we want is Java. We want Java 8 running on a 64-bit Amazon Linux machine, and we're going to use platform version 2.11.5. We do want to upload our own code. We're going to give it a version label, DES Microservice 0416-source 001. Again, these names, you can change those. And we are going to upload a local file, which is that same artifact ID.jar file we talked about previously. After that's done, we go down here to our create application. That will take us to an intermediate screen, which is going to have a whole bunch of progress, log messages, as well as any potential errors or warnings that you may see. Hopefully, if the upload succeeds and the microservices are properly hosted by AWS, then it should bring you to a screen like this, very similar to the one that we saw when we deployed our servlets on Amazon Web Services Elastic Beanstalk. We click on this link right here, and that brings it up in the browser. And you can see that what we're going to do is we have the part of the link that was provided to us by AWS. We can't forget to add URL pattern A. We then have to put gen, I don't have enough room, random number, as well as question mark, and then our string and equals to something. And so you can see the addition to the URL. So everything from this point to the left is provided by AWS. Everything from this point to the right is the same as our previous URL patterns that we defined. URL pattern A, the name of the microservice, input string equals Professor Dees. And the result that we get, the same as what we saw when we locally deployed these microservices. So now let's talk about some potential applications for this example, and then we'll close up the module. So let's ask that question. How could something like this example, be useful to you? Let's say you're building a mobile application, one that needs to perform computationally complex operations. Examples could be machine learning, could be accessing a relatively large table. But the application also needs to be compatible with older phone models, which lack the computing power to effectively perform these tasks. Now, what can you do here? One option is to create your own set of microservices hosted in the cloud to perform the more computationally complex parts of the app. Then what we do is we call our own microservice from the mobile device, acquire the results from the cloud service provider, and then effectively integrate more advanced capabilities into our applications regardless of what computing power is available locally, regardless of how old the mobile phone that we're working on is. Now, we presented a relatively simple example, I know that. However, for someone with sufficient background in Java development, and that doesn't really have to be that much background, this module provides all the basic components and instructions required to implement some pretty advanced cloud-hosted APIs composed of microservices.